The goal for today is to graph polynomial functions. To graph a polynomial function, we need to 1. Find all the zeros. 2. Perform a sign analysis. And then lastly, graph it. So let's take a couple easy ones. Example 1. Let's let f of x equal negative x times x plus 2 times x minus 2. Number 1, find all zeros. The zeros are explicitly given to you basically. X equals 0, negative 2, and 2. Lastly, we do a sign analysis. This is something new for you. A sign analysis is basically a number line where we put the zeros on it. So add 0, we have an answer of 0. Add 2, we have an answer of 0. Add negative 2, we have an answer of 0. This skill we use widely throughout the course as well as calculus. Lastly, we plug numbers in from each interval to see if they're positive or negative. You don't need exact values, you just need to know if they are positive or negative. So for example, plug in 3. You plug in 3, we have a negative number here. Plug in 3, we get a positive number here. And a positive number here. Therefore the answer is negative. If you plug in 1 from here, we have a negative, positive, negative. Therefore it is positive. If you plug in negative 1, you get a final answer of negative and then positive. This tells you how your graph looks. You know you have x-intercepts at negative 2, 2, and 0. If the graph is positive, it must be above the x-axis. If it's negative, it must be below the x-axis. If it's positive, it must be above the x-axis, and negative below. This graph makes sense because it's a cubic function and is decreasing due to the negative sign. So let's try another one. Let's let f of x equal x cubed minus 7x squared plus 15x minus 9. Notice, obviously, I didn't make this one easy on you. You don't have the factors. The next part would be how could we factor it. You could try grouping, but it does not work. So we're going to have to use synthetic division. So I'm going to have to tell you more information. I'm going to say that you have one root, that is x equals 3, and then it's a double root. Let's see what that means in a second. So if you know that's a double root, we can plug it in right away. Plug in 3, 1, negative 7, 15, negative 9 up top. If it's a root, this better be equal to 0. If not, we're in trouble. So 3 times 1 is 3, negative 4, negative 12, 3, 9, we got 0, it checks out. Going back to the remainder and factor theorem, we now know that x equals 3 is one solution, or one x-intercept. And we're left with the expression x squared minus 4x plus 3, which we can factor. This becomes x minus 3 times x minus 1. Therefore, our expression factors into x minus 1 times x minus 3 squared. This is why it's double root. So now let's do our sign analysis. We know the zeros are x equals 1 and 3. Again, 3 is a double root. I always like to notate that. So let's plop 1 down there with 0, and 3 with 0. I also want to put a double root there, just because it helps you realize that your sign analysis is correct. You'll notice the pattern after doing a few examples. Let's plug in the answer of 4. Notice this is always positive. When we square this, it's always positive, so we can actually just ignore that. Plug in 4, it's positive. You plug in 2, it's positive. You plug in 0, you get negative. Therefore, our graph looks like it's negative, comes up to positive, dips down, touches, and then bounces back up. It never goes negative there. It's tangent to the x-axis. That's what makes it a double root. It actually looks like a parabola right there, which is why it's called a double root. The last example I would like to do is f of x is equal to x to the fourth minus 2x cubed plus 2x minus 1. We know that x equals 1 is a triple root, which means it should show up 3 times. So let's do our synthetic division. Don't know why I made it that big. 1, negative 2. Don't forget the 0. 2, negative 1. Again, this better work because I'm telling you up front that it's a triple root. 1 times 1 is 1. Negative 1. Negative 1. Negative 1. Negative 1. 1. Negative 1. 0. Notice this would mean this is x cubed. We still might not be able to factor it, but if I told you it's a triple root, we can just do it again. What you're doing now is basically just factoring it using synthetic division multiple times. 1 times 1 is 1, 0, 0, negative 1, negative 1, 0. And so you're left with now these two as answers, and this is now our expression. This was x cubed, now this is x squared. So we're left with x minus 1 times x minus 1 times x plus 1 times x minus 1 when I factor this down here. Therefore, x equals 1 triple rooted at negative 1. If we do our sign analysis, again, I'm notating that it's a triple root. We now have, you plug in 5, positive, 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 positive. Plug in 0, you get negative, negative, positive, negative. And you plug in negative 2, you get negative, 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 so positive. Since I know it's a triple root, it forms a certain pattern on the x-axis. It comes positive, sorry, that's really bad. And then the triple root has to look like a cubic function there. So it looks cubic. So basically you have 3 types of roots. In the first problem you had a single root. So it just kind of goes through like it's linear. The roots model a line behavior. On a double root, it's tangent, it looks like a parabola type behavior at that root. And for a cubic root, or a triple root, it looks like the cubic function right at that axis, right at that intercept. So our procedure for graphing polynomials is simple. You find the x-intercepts, which is obviously going to be a daunting task. The question you should have for me is, I'm giving you this now. Eventually you have to figure that out. That's going to be the challenge. So you have to find that answer, factor it completely, do a sign analysis, and then graph it. Thank you.